Welcome you all, my dear students. Now, this is the fourth video on shear force and bending moment diagrams. In the first video, we discussed about basics, and in second video, we discussed about cantilever standard beams. There are some standard loads and for distance L, this standard cantilever beams we have discussed. Third one, we discussed the cantilever beam with um, combination of various loads. It might be point load, UDL, or combination of UDL and point load. Okay, the third video. The fourth video, we are now jumping towards this shear force and bending moment for simply supported beam. SSB stand for simply supported beam. Okay, in the first video we discussed already that what is the procedure to draw shear force and bending moment. In that one I have already explained the first step to determine to draw this SFD and BMD. First step is draw free body diagram for supports and loads if any. Okay, this is the first very important step. Second step is draw support reactions, or otherwise determine support reactions. When you determine support reactions, then only you can proceed to draw SFD and BMD. Then the third point is determine shear force and bending moment at various locations. Then this is after this you will draw it, right? These 3 points we have to discuss. But you already know that while discussing cantilever beam, then we ignored first two methods. Why? Because that is already explained in the previous videos. Now we are discussing for simply supported beam. Therefore, we cannot ignore first and second. We have to consider this and this. Then we have to proceed. Okay. That therefore always remember the first step is free body diagram and second step is support reactions. After that only we can go for shear force and bending moment. Okay, now in last chapter or otherwise in engineering mechanics we are already discussed how to determine support reactions. Okay, that I will not go deep into this how to determine support reactions, because there in that chapter we have discussed or otherwise we have undergone through various combinations of loads and even complicated beams. You have discussed how to determine support reactions, right? But when I go, this is the fourth video, no? When I discuss about the fifth video, there shear force and bending moments will be drawn for combinations of various loads. There I will explain you how to determine support reactions. But here we are discussing simply supported beam standard loading. Standard loading. Here I may go very fast and skipping this support reaction point or taking advantage of symmetry of the beam, then I may solve that one. Therefore, the first point in our step, the first point drawing FBD and the second point determination of support reactions, I may go very fast here because this is a prerequisite for this chapter. The third point I will concentrate and I will explain very deeply how to draw SFD and BMD for these standard simply supported beams. This is very important, standard simply supported beams. Right now, we'll go one by one. The first one here is simply supported beam carrying single moment at its center span. Okay, let us consider simply supported beam. Simply supported beams means one side hinge and other side roller. This is a simply supported beam. And here I will consider the free body diagram. This will be one force here and this is another force here. We can call this as a RA and this one as RB. Right? Now at this point this is a hinge, therefore you will be having HA, horizontal reaction at A. But while dealing these problems, today's problems, I am considering only vertical forces. Therefore, I can ignore this horizontal force. Means here reactions means I will consider both RA and RB alone. Now, moment at its center, they said. Therefore, this is the center point where moment is applied. This is m. This m is a moment. Right? Now the distance between this one is L by 2 and this distance is also L by 2. Now the first thing is that I have to determine support reaction. For that support reactions, I will use a summation of m at A is equal to 0. Then at this point, this m is clockwise, therefore positive. You have to use this sign conventions for support reactions, and here you can write clockwise positive, anti-clockwise negative. Then now this is the clockwise positive, therefore m is clockwise positive minus rb into L equal to 0. Now what is this rb? Rb equal to m by L, positive. Rb equal to m by L. Okay, then summation of Fy when I use, then this will be minus m by L, that is your Ra equal to minus m by L. Right? These two support reactions I got. Those two support reactions I will write in the beam itself. Ra equal to minus m by L. Remember this. Then Rb equal to plus m by L. These two are support reactions. Right? Now we will determine shear force and bending moment. Okay, you should know when I draw shear force, there is a rule. That rule is wherever point load is there, two sections you have to consider. Then another rule for bending moment is wherever moment is there, two sections you have to consider. Now first one, name this point as a point, this is the B point, and middle one is the C point. Now shear force at at A. At A you cannot take, therefore left of A, and observations I will make it left side. Observation left side. Now see, this is your section, and you are making left side observation, nothing is there, 0. This is the first one. The second one is shear force at right of A equal to, now shear force at right of A means the section will be here, but observations I will make again left side. Now look at here, this is my section. Left side, when I see this RA, I am seeing RA means minus W by L. Okay, that I am seeing minus W by L. Now left side upward is what? See here, this is left side upward is positive, therefore this is positive. Therefore minus W by L is the answer. Next, third one, I will consider at M. No, not required, because I am doing shear force. At M is not required because that is not a force, vertical force. Now coming to shear force at left of B equal to, left of B means we'll consider left of B, that is this section. Then observations will make right side. When I see right side, then I am seeing this load, that is m by L, vertical force. Then right side upward is this one. The right side upward means this is negative, therefore the answer is minus m by L. Okay, now I got this one. Then shear force at right of B is equal to 0. This much I got. That I will draw here. Now look at here. What is the shear force at A? Is a 0. What is the shear force at B? Is a minus m by L. This is minus m by L. And what is the shear force at B, that is minus m by L, then what is the shear force at that one? 0. Therefore, you will get this negative diagram as a shear force diagram. Right? Now we'll go for bending moment diagram. Now bending moment at A, bending moment at A, observations, we will make it left side, nothing is visible, therefore 0. Bending moment at left of C means this side, observations, we will make left side. You are seeing one force with the distance is causing the moment, that is minus m by L is a force which is causing a moment with a distance L by 2, and this one, and this is in this direction, that is resembling with this direction, therefore this is positive. The answer is minus L cancel, m by 2 is the answer. Okay, then bending moment at right of C. Bending moment at right of C, observation right side will make. Observation right side. Now this is my section. I will see this side. When I see this side, then the force is m by L, and distance is L by 2. L by 2. And these two forces are causing this moment, and this arrow mark is resembling with this one, that is positive. Therefore, L cancel, m by 2 is the correct answer. Now, what is the shear force diagram for this one? Sorry, bending moment diagram. At this point 0, at this point 0, you can write here bending moment at B equal to 0. Now, at this point, C point, from A to C, that span, you have minus m by L, m by 2, and here you have a plus m by 2. Then this is your bending moment diagram. This is positive and this is the negative. This is m by 2 and this is m by 2. Right? This is shear force and bending moment diagram for simply supported beam carrying single moment at its center span. Okay. Now we have discussed about center span. This you consider it as a homework. The homework is simply supported beam, but this time anywhere in the beam. Anywhere in the beam means I will consider a moment m acting here, and this distance I will call A, and this distance I will call B. Okay. Draw SFD and BMD for this beam. Just think of, understand this one, and you can draw this beam. Now the third problem. This is a simply supported beam. Point load P is acting, and this support is a reaction at A, and this is a reaction at B. This is A and this is B. We'll call this point as C. Then you must know that if this is a P, and we'll take advantage of symmetry. Symmetry means from the center, this side and this side equal portion and equal supports. Therefore, this is P by 2 and this is also P by 2. Right? Now we will write shear force diagram. Okay. First, wherever point loads are there, two sections you have to take. Shear force at left of A. Shear force left of A means outside the beam. Outside the beam. For that outside the beam and observations we will make left side. Left side, nothing is visible, 0. Then second one is shear force at right of A. Right of A means this one. Then again observations will make left side means this side. This side you are seeing P by 2. Okay, this p by 2 is positive or negative? Left side upward, left side upward is a positive. This one, this is a positive, therefore this is positive value. Then after that we want shear force at left of C. Left of C means this one, and observations we have to make left side. Okay, then observation will make left side, therefore this is equal to p by 2. Same thing, because left side you are seeing only one vertical force. Now shear force at right of C means shear force right of C means this one, and observations will make right side, because this is easier, therefore right side I will see. Right side you are seeing vertical force as p by 2, but right up negative, therefore negative, it is run right up negative, right up. Then after that we'll come to this point, this is over. Now shear force at left of B. Left of B means this section, then observations will make right side. Okay, right side means you are seeing only one vertical force, that is p by 2, and right up negative, therefore it is negative, right? Over shear force at right of B is equal to 0. This is over. If you draw shear force diagram for this, then it look like this. At this point 0 and plus p by 2, therefore this is a 0 plus p by 2. At C point, one is plus p by 2, another is minus p by 2, therefore one is plus p by 2 and another is minus p by 2. And after that B point minus p by 2, this is minus p by 2. No load, therefore rectangular box, rectangular box. This is plus, this is minus. The value is p by 2 and p by 2. This is SFD, right? Now we will determine shear force bending moment diagram. Bending moment at A equal to means at this point. First we'll drop this one. Bending moment at A means take a section at this point, look at, observe at left side, therefore 0. Then bending moment at C point. C point means this one. Now we'll look at left side, observe left. Then what you are seeing? You are seeing moment there. You are seeing moment produced by P by 2 force. That P by 2 force is produced in moment when it is multiplied with the L by 2. This is L by 2. And this is causing this direction. This is resembling with this one. Therefore, it is positive. Therefore, PL by 4 is answer. Now, if I draw bending moment diagram, then this is 0, this is 0. At this point, we will get PL by 4. This is PL by 4 is a bending moment at its middle span. That is the maximum bending moment for simply supported beam. This problem completes. Next problem, it is just like this only. Okay, you write all these points and calculate. I will give you the final answer, that is the diagram, shear force and bending moment diagram for this draw load. Shear force, simply supported beam carrying point load anywhere in the beam. Anywhere in the beam means I will consider A and B. Then support reaction you must know from the previous chapter, that is RA is equal to PB by L and RB equal to PA by L. Then your shear force diagram will be, this comes down, then after that further down, then horizontal, then this one. This value is PB by L. This is also PB by L, and this is PA by L. This is PA by L. This is negative and positive. Then bending moment diagram, you will get it from here. The maximum below the point load and straight joining, and this maximum height is PAB by L. PAB by L is a maximum bending moment. Okay, you work out this side and you will get the same answer. Next point is simply supported beam carrying 2-point load at a distance L by 3 from both supports. Now we have a simply supported beam. This is support and this is support from that L by 3 and from this L by 3. Therefore, in between also you will get L by 3 because total length is L. Now in this case, you should know how to determine support reaction. We will take advantage of symmetry, and this beam is symmetry. Therefore, whatever the point load P is there, that P will apply here. The reaction is also P here, and the reaction here also P. Okay, now we'll call this point as A, this point B, this is C, and this is D. Okay. Now shear force diagram we have to draw, and all loads are point load. Therefore everywhere we have to take two sections. Now I will take advantage of symmetry here. Symmetry advantage means, no, we will not take any advantage of symmetry because shear force diagram is not symmetric. That's why we will not take any symmetrical advantage. We will calculate as usual. the first one the first one, this is shear force diagram at left of A equal to 0 because observations you are making it left side. Then shear force at right of A. Right of A means this one you will consider as a section, and observations you will make left side. Only one force is appearing, that is P. Next, shear force at this one, left of C, left of C, and observations we will make left side. Again only one force you are seeing, that is P. Okay. Then shear force at right of C. Right of C means this shear force, and observations will make it left side only. Therefore P minus P equal to 0. Now shear force at this side will come, will take left of D, left of D, but observations will make it left side only. Therefore you will get P minus P 0. Now shear force at right of D. Right of D means this one. This time we'll make observations right side. Only one force you are seeing, that is P. But right side upward is negative. Therefore minus P. Next one is shear force at left of D, left of B. Left of B means this one. Observations will make it right side. Only one force, that is P, and right up negative. And now we'll come to shear force at right of B. Observations will make right side, therefore it is 0 over. Now we'll draw shear force diagram for this. The shear force diagram is at this point 0 and P, these two, 0 and P. Okay, at C point we have two, P and 0. This is P and 0. And at D point we have 0 and minus P. At D point we have 0 and minus P. And at B point we have minus P and 0. Minus P and 0. Now here this is like this and this is like this, because here 0 and anywhere you can calculate, that is 0 only. This is positive, this is negative. This is shear force diagram. Then after that we'll draw bending moment diagram. For bending moment, first point, bending moment at A equal to 0, because at this point right side no forces are, left side no forces are there. Like that, bending moment at B, this point, right side nothing is there, here also it is 0. Now I'll come to C point. Bending moment at C, bending moment at C means this point. Then observations will make left side. When I make observations left side, this one force causing moment, that force name is P, and that causing moment with the distance L by 3, PL by 3, and this is direction, and this is resembling with this, therefore it is positive, PL by 3. Then I will consider bending moment at D. Bending moment at D means this one. Then this time I will observe right side. Observation right side, then force P is causing moment when it is multiplied with L by 3. This will be this direction, that is also resembling with this, therefore positive. This is also PL by 3. Now I will draw bending moment diagram. At this point 0 and this is 0. At this point it is PL by 3 and this is also PL by 3. Therefore you will get this is bending moment diagram. Right? This is PL by 3 and this is PL by 3. Okay, here we will make one conclusion, very important note. We will write it. The note is very important note. The note is wherever wherever shear force is 0, shear force is 0, for that span, bending moment is constant. Bending moment is constant. Span I am considering, not a line, point. Just I am considering this span, shear force is 0. For that span, bending moment is constant. That is constant for the particular span. This you can remember, and later chapters you will understand that this case is considered as a pure bending case. This is considered as pure bending case because at this part of the span, you are observing only bending moment, not shear force. Therefore this span of the beam is considered as a pure bending span. Right? You can note it down. Then take it as a homework. Then here what happens, bend shear force diagram. Before that we have to find load, support reaction. Let us consider P and P plus P plus P 3P, and this is 1.5 UP and this is 1.5 P. I took advantage of symmetry because L by 4 L by 4 L by 4 L by 4, 1.5 P. Now what happens, you can write a shear force diagram. This is 1.5 UP constant, then it reduces to this one. This is your 0.5 up, 0.5 up constant, then 0.5 here and 0.5 here. This is 0.5 up, then from here it goes, then it again comes down. This is 1.5 up, then it goes, then you will join it. You can check it. I have drawn with some hints here. That hint will be explained after completing this chapter. Okay. By that hint I have drawn, you can write it for every sections. You take a shear force, left of A, right of A, left of B, right of B, left of C, right of C, left of D, right of D, and left of E and right of E. Like that you will write all the points how we wrote here. The same way we will write it there and we'll get this diagram exactly. Now if I want to draw a bending moment diagram, then bending moment diagram will be 0 here, 0 here, and you will get one load here, one load and another load. 1.5 into L by 2, 1.5 into L by 4. Therefore 1.5 by 4 is 3 by 8. Okay. Here you will get a bending moment diagram 3p by 8 L. Right. The same way symmetry is there. Therefore here also you will get a same thing. Okay. Then at mid span, at this span, then you can multiply. I will write that only. Bending moment at C. Bending moment at C. Then observe left side. Then what you will see? You will see 1.5 P, which is multiplied with L by 2. That is one force which is in this direction, resembling to this positive. Then we have another force P multiplied by L by 4. Then this is in this direction, resembling to this, therefore negative. The answer is 1.5 by 2 is 3/4. 3 PL by 4 minus PL by 4. 3 PL minus PL is 2 PL by 4. Therefore the answer is PL by 2. Then you will get a bending moment diagram with PL by 2. Okay. You cross check this one, then you will get the same answer. Alright. Now coming to the UDL. This is a UDL. Here first I have to convert this UDL into point load. For that I will draw a dotted line. This is for my reference, and the load here it might be a W intensity. W into L is your point load. Right? Now shear force diagram. Shear force, for that this is A and this is B. We'll find support reaction. The total load is WL and symmetry is there, therefore WL by 2, and this is also WL by 2. This is because of symmetry. Now shear force at left of A means this side, that is obviously 0. Next one is shear force at right of A. Right of A means this one. Observe the observation left side. Observation left side. You are seeing only one force, WL by 2 and positive. Next one, shear force at left of B. Directly we jump to here. Now this time I will observe right side. We'll observe right side. You are seeing only one force, WL by 2. WL by 2, but it is negative because right side upward negative. Next one, shear force at right of B. Right of B. Right of B means this one, then nothing is seen, 0. Therefore, your shear force diagram is this is 0 and WL by 2, 0 and WL by 2, and at this point you have minus WL by 2 and 0. This is minus WL by 2 and 0. Wherever UDL is there, you have to join with the straight line. Therefore, this is your right answer. Okay. Now, after that, we will draw bending moment. Significant points we have two, that is bending moment at A equal to bending moment at B equal to 0. Okay, these 2 points are gone. Now coming to the C point. C actually we should not determine, but you don't know, no? Then how to join this point and this point? Something must be there, no? Here. Therefore, bending moment at C I will find out. When I take bending moment at C, I have a right to observe either left side or right side. I will choose observation left side. Observation left side. The left side, what all forces are there? For that left side UDL, we will convert it into point right. Only this span UDL. Only this span UDL will convert. That is WL by 2. W into this is L by 2. Therefore, WL by 2. That WL by 2 is causing some moment with a distance L by 4. This WL by 2 causing distance in this direction, that is resembling with this negativities. And another force is there here, that force is WL by 2. This WL by 2 is also causing a moment, but this time the distance is L by 2, and this is positive because this arrow mark resembling with this one. And now W L by 4, this blue ink, minus this red ink is WL by WL square by 4, and this is WL square by 8. The answer you can cross verify, WL square by 8 is the correct answer. Now this WL square by 8 will be at the middle span, and you have to join this with the parabola. Okay, then the maximum height of the parabola is WL square by 8. Okay, here we will make one very important note. The very important note is wherever shear force changes sign, there bending moment will be maximum. Bending moment will be maximum. Now here you can see this is positive and this is negative. Shear force is changing at this point, then the corresponding point you will get a maximum bending moment. Right? This is sort. Now we'll come to simply supported beam with UDL. For this one, first I have to draw free body diagram. Here the dotted line I will consider. This dotted line and intensity is W. W into L by 2, distance is L by 2. Therefore WL by 2 is your UDL. Right? Then support reactions. You should find out support reactions. For that I will write summation of M at A equal to 0. Now support reaction sign conventions I have to use. This is A, this is B, and this is C. Now what is this distance? This is L by 4 from this assumed point load. Now assumed point load WL by 2 is causing a moment, that is WL by 2 into L by 4, which is clockwise in direction, therefore positive. Next, this RB RB is also causing a moment at A is anti-clockwise direction minus. Only this force and this force equal to 0. Now you can cancel, take a common of L, and you can cancel one L. This L and this L cancel. Then RB is equal to WL by 8. This is WL into 4 into 2, 8. This is RB. Okay. Now summation of Fy equal to 0. Summation of Fy equal to 0 means this is RA upward minus WL by 2 plus RB. RB is WL by 8 equal to 0. Therefore RA equal to WL by 2 minus W by L means I will multiply 4 here into 4 here, 4 into 8, and this is minus 4 plus 1 is minus 3, and send it that side, that is plus 3 WL by 8. Okay, 3 WL by 8. Okay, this is RA and RB. From this you can draw shear force diagram at this point 0, and RA is 3 WL by 8, therefore something bigger here, 3 WL by 8. Now at RB you have WL by 8, that WL by 8 is something like this. Okay, wherever there is a point load, if I take shear force at this point, then what happens? Right here, only important points only I am taking. Shear force at C equal to C section, then look at right side. When you see right side, this force is WL by 8. WL by 8 only one vertical force, therefore WL by 8. This is also WL by 8, straight line. Then after that you will see one inclined line like this. Okay, this is your SFD. Now after that, if I draw BMD, then obviously BMD is 0 here, BMD is 0 here, but at this point BMD is WL by 8 into L by 2. Therefore WL by 8 into L by 2. WL by 8 into L by 2 is WL square by 16. At this point WL square by 16. This is okay. But here you have to remember, in previous slide we have shown, wherever shear force changes sign, there will be maximum bending moment. Means here shear force is changing the sign, therefore I will just drop it down. At this point I should get maximum bending moment. For that I have to draw a parabola in such that it goes and reaches a maximum point and then comes down. Okay, this is our maximum shear force diagram. Oh, sorry, maximum bending moment diagram. Okay, now you can find this distance, calling this as a x, and this one is L by 2 minus x. Then by using similar triangular method you can find the x value. After finding x value, even you can determine bending moment here. Okay, this problem in the next class I will consider as a numerical problem, and I will solve you this one with the LPW. Is very complicated, right? Now UVL. Okay, you take it as a homework. I will give you the shape. The shape is this is your shape for shear force diagram. Then for maximum bending moment diagram, okay, then it is your duty, because it is 0 here, there I should get a maximum point. Then it is your duty to find out this one and this one, right? Over. In the same way, this shear force diagram shape will be like this, and bending moment diagram like this. This video is taking too long, that's why I have not solved this one. In the next video I will give you the value of this and the maximum bending moment, the value of shear forces and maximum bending moment. Thank you very much.